Hello and welcome everyone. This video is continuation of our RAG tools series, and in this video we'll be talking about web scraping. So web scraping is essentially a concept where you would visit a website and you will extract the content out of it, right? So let's take a very simple example where you want to find some information online about something. So you would go to Google and you will say that, let's say, open AI compatibility for Olama. And you go over here and then you see one of the results on the top, right? You click on this result and now you are reading this article. So if an LLM has to do that, if our large language model application has to do that, then how would we achieve this? So this is the whole scenario that we'll be taking today. And I'll be walking you through how you get the content out of the web page and how you get a good quality content out of the web page, right? So I'll show you several examples where first we will get the information out using simpler tools in Python like BeautifulSoup4, and then we will move on to some more advanced tools using Crawley and Playwright. And we'll also see how some more professional or more production ready applications are built using such tools, right? So you may have come across tools like Firecrawl and all that, and we'll talk about that later in the video. But if you stick till the end of the video, I'm pretty sure you will learn a lot about web scraping tools and technologies and how you make a production grade web scraper tool. And I'll be sharing in my GitHub repo this web scraper with you guys that you can directly use if this video is too long. But if you want to see and understand how this tool is built, then stay along the journey with me over here. All right. So at a very high level, let me show the diagram over here, and it will make sense with this diagram. So if you are interacting with any large language model, let's say with Llama 3.1 or GPT-4o, and you ask any complex question on which that model has not been trained on, right? So the model will either hallucinate or it will give you a reply back. For example, the same question that I went on Google just now, if we ask this question to our Llama 3.1 model, right? What is the OpenAI compatibility for Olama? So this question, if you see, this blog is fairly new. This is February 8, 2024. So it's very highly possible the likelihood of this particular information in Llama 3.1, it won't be there, right? That this information cannot be there because Llama 3.1 was trained before this cutoff date. So if we send this information, right? So if we request Llama 3.1 with this information, then most likely it will hallucinate. Let's do that. So you see that there is a client over here already. Let's take the example from here and let's ask this question to our Llama 3.1 model. So what I'm going to do is I'm going to send a curl command to localhost 11434 v1 chat completions, which is actually the OpenAI endpoint. And I'm going to ask Llama 3.1 70 billion parameter model, what is the OpenAI compatibility for Olama, right? So this is exactly what I'm doing. I'm going to ask this question to Llama 3.1 model from the command line, and let's see how it responds back. So I'm going to go over here, and you can run this from any terminal as long as you have Olama installed and you have Llama 3.1, any large language model pulled in there, right? So you can see I have made a ton of videos on Olama and also Llama 3.1 installation, server setup, and all that. So you can find some of those videos to see how Olama is installed. But in this video, we'll assume that you have Olama installed already and you have Llama 3.1. So let's run this curl command, and all I'm doing is just sending this particular request to Llama 3.1 70 billion, and let's see what the response comes back with. So in my case, let's see. I think the model is right now loading, and it is not streaming response. It is getting the whole response back, and here it is. So the response over here says that a very specific question. After some research, I found that Ollama is an AI model developed by Meta AI and whatnot, but I don't think it could answer anything related to our question, right? So it cannot answer the OpenAI compatibility question over here because it does not know about it. So 3.1 70 billion parameter, being a smarter model, did not really hallucinate, but I think it just gave some answer over here. So to answer your question, OpenAI's compatibility with Ollama refers to an extent to which models or tools developed using one framework can work seamlessly from another, right? But it is saying as of its cutoff date, Ollama is built on top of PyTorch, which uses transformer-based architecture and whatnot. But I don't think it is saying that it is aware of its capabilities, right? And which is fair enough. This model will not know about it. So in these situations, how do we get an answer, right? So we do want an answer like this from our large language model, but the large language model is unaware of such context. So how do we get such an answer? And this is where we take a look at an application architecture called RAG. So in retrieval augmented generation, and there are many multiple ways of defining it, but in general, you ask a question and the question is routed to a knowledge base. And then instead of just answering the question directly, some relevant documents from knowledge base are extracted, and then the question plus the context of those relevant documents are sent to the large language model, and then the large language model responds back, right? So there is a knowledge base that the application utilizes before naively answering the question. Now, the question is, how do we know that this knowledge base has the answer to our question, right? So as a human, we can always go to Google and we can search for whatever we want. And when we search for it, we click on the right results and then we are able to see an answer. But as a large language model, how do we know that the large language model is able to do that? So the way we do it is we take the question and we do an internet search, right? So same way in which a human is doing an internet search over here, right? So we went to Google, we did an internet search. In the same way, we can have a Python code do an internet search. And this is not the focus of this video, but I'm just talking about the whole approach. And I will also talk about what is the focus of this video in a minute. So we do an internet search and then we click on the first link, right? As a human, we click on the first link and then we read the document. This is the focus of our today's video, where we will have decided which document we want to scrape from and create a document out of it, right? So as a human, I'm able to search and I'm able to take a look at this particular page. How do I make large language model look at this page? This is where web scraping comes into picture, where you have decided which web page you want to extract the content from, and now how you extract that content and provide it to large language model. This is where the web scraping comes from. The concept of web scraping comes from. So if you right click on this and look at the page source, right? So one thought you may have, hey, we'll just take the page source and we will send it to large language model. But just take a look at this. How ugly is that, right? I mean, this page is really a lot of noise for such less amount of data that we actually want from here, right? And this is a very simple page, and yet it has so much of noise over here. And if we take a look at some other complex pages, right? And I was taking a look at some of the help documentation on SAP. So let's open this particular page over here. And this is one of the help documentation pages. And you see how the JavaScript loaded at the front and then this page loaded over here, right? So I'm going to refresh this again so you can see. So see how these JavaScripts was loading and then this page was loading over here. And if you go and take a look and inspect this page, or review the page source rather, then you will see that this is actually not a very simple page. So the content over here is actually nothing. If you see, the content is nothing over here, right? So, but this page is rendered in such a pretty way. So you have all the content over here and nicely formatted and stuff, but because it is using JavaScript, right, getting the content out directly is hard. And these are some of the challenges that we will solve today. We'll take a look at some simpler web pages like this particular web page where the content is all there, but if you see the page source, it is very ugly. How do we get rid of this ugliness and extract only the pretty content? And how do we then move on to more complex web pages and extract content from there? All right. So there are some professional grade solutions out there already. I want to mention that first, right? So for example, Firecrawl. If you take a look at this particular tool, I mean, of course, there is some pricing, and I'm pretty sure there are some free credits. I think 500 pages you can scrape, 10 scrape per minute and all that, right? And maybe it is okay for some of us to use such open source, non-open source, closed source tools, right? However, I like doing everything locally, and I want to learn on the way of developing these applications too. So I want to see what are the good things that this Firecrawl provides. So it provides any particular website URL. If you give it, it will convert it into a markdown format, which is awesome, right? So you will take, let's say if we take this particular website over here and we go and we convert it. I don't know, maybe it won't give us right away. Oh, it actually will show us. Okay, awesome. So I just want to show you that what's the difference between the regular and the markdown. So see how nicely the markdown content is laid out over here, and it got rid of all that crap. It got rid of all these meta tags and all that. These are unnecessary for large language model to process. We don't need to send all this information. We just need a clean information, something like what Firecrawl has done for us. So how do we create a tool similar to Firecrawl, right? That can take a web page URL and convert it into a markdown format. Before we understand all this, I think we need to understand how this whole concept of web scraping is working in Python, right? So there is one library in Python which you will come across anytime when you talk about web scraping. You will come across that library, which is, and let me increase the font size over here so you guys can see it easily. And Control plus again. Okay, all right. So as I said, this is a larger project of React tools, which I've been talking about in past couple of videos. So this is the web scraper folder in this larger project. So if you go to my repo, in this repo teaching React tools, there is a web scraper. And in this web scraper, these are the two tools that I will talk about: tool internet scrape and tool crawly scrape. In tool internet scrape, I will show a basic web scraping example, which will get you familiarized with the concepts of web scraping. And in the tool crawly scrape, I'll talk about advanced web scraping technologies and how they come together using the foundations that we built on the tool internet scrape. All right, so in this first tool internet scrape.py, this is where we'll be using the very first library. We'll get introduced to BeautifulSoup. So what is our BeautifulSoup library? So BeautifulSoup library is a powerful tool for parsing HTML and XML documents. And in this script, I will demonstrate how to extract specific content from web pages such as paragraphs and how to stitch them together and process them and store the data efficiently, right? So you'll see that there are certain imports on the top. I have requests, Beautiful Soup, data class. So Beautiful Soup, I already talked about. This is the code library that we are using for parsing the HTML content that is fetched by the requests, right? So let me open this in here in the Netscape. Okay, perfect. So requests library is used to make HTTP requests to a web page. Of course, it's a simple and effective way of fetching the content out of the web page. And then the Beautiful Soup, this is a core library that we are using for parsing the HTML content, right? So the HTML content is fetched by requests, and Beautiful Soup is being used to parse that content. And this also allows us to navigate and search through the HTML structure. Now, the data class. So what I want to do is I want to return the information back from this tool in a very structured response, right? So what I'm doing is I'm creating a scrape data class over here. And in that, this is a typed class, right? So we have website name that we are going to scrape, what time we are scraping that website, and list of all the stitched paragraphs and total words in this particular list of paragraphs that we have. So I'm going to create like a set of information that I want to return back from the scraped website, which is why I'm using this particular data class over here. And then date, time, and then URL parse and all that are being used for extracting some of the URL content, which I don't even think that I'm using it anymore, but you can use it in case you want to extract just the website's name, just the domain part of it. All right, so if we run this particular script over here, you'll see that in this script, we have an extract content method where we are first getting the response back by running the requests on this particular URL, and we are getting the response back. And then on that response, we are getting the soup out of it, right? This is a very common terminology when using Beautiful Soup. You're getting the soup out of it by getting the response from your HTML parser, right? So you're parsing the content out, and then you are assigning it to the soup. All right, so once you have done that, then you can get all the paragraphs out, right? So you can get the paragraphs out from the soup that you have already created, right? So you have step number one, you get response from your request. And then from this particular response, you get the text out, and you use the HTML parser over here to get the soup out, right? So from the response.text, you get the soup out, which is the content of that web page. Once you get that soup out, then you can get all the paragraphs that are within that particular HTML soup. And once you get all the paragraphs out, you can get all the text out from those paragraphs. And then you can get a list of all these paragraphs over here. And then there's another function over here to get the all the words, the count of words, right? So total number of words. And then we are stitching all this information back in form of scrape data, right? So remember, we created a scrape data class over here so that we get all the information back nicely in this format. And then we can return it from this extract content. So this is a very basic, simple example, right? Where we get the response, we get the soup out, and then from the soup, we get all the paragraphs out, and then we can print that paragraph. Okay, so now let's run this and let's see what is the response from this particular page, right? So this is the same page, OpenAI compatibility page. This is the same page that we have. And what we're gonna do is we're gonna run this extract content for this URL, and then we want to print this data. So remember, this data is actually this data class that it is being returned, the scrape data, and we will see the results. So how do we run this? So there is a README file over here, right? So let me quick show you this README file so you'll know how to set up everything. So in README file, you will see that it's asking you to clone this repo, go into the CD web scraper, so this particular directory, and then you can create a Conda environment, right? Not necessary, highly recommended, create a Conda environment, and all this Conda installation and all that is already in my previous videos I have covered. But if you do not know what it is, I'll link my videos and then you can take a look at over there. So create a Conda environment, activate Conda environment, do a pip install. And this pip install requirements.txt, there are a few installations that you need to do. And many of these will be required for your crawly part of it, but for this tool internet scrape, you only need BeautifulSoup4 and requests. Only these two are needed. But why not just go ahead and do the whole pip install, right? So do this pip install requirements.txt. And then these two will be required for the crawly setup, but go ahead and do that. Do a playwright install dependencies and then playwright install, and then that would be it. And then once you have done these 5 steps, right? Once you are done with these 5 steps, then you will be able to run this particular script over here, right? So you see how the Conda activate web scraper was over here, and I've already activated it, and I am already CD'd into the web scraper directory. So I'm already in here. So all I have to do now is to run tool internetscrape.py. So this is the file that I'm going to run, tool internetscrape.py, and let me run that. So Python tool internetscrape.py, and I'm gonna hit enter, and now it scraped and it gave me this content out, right? So it is a scrape data. We got text out of our HTML page, and it doesn't look ugly, right? It's a very decent looking text. So it has information around how we want to structure our context essentially for this particular question that we were going to send, right? So let's do this. Let's copy this whole thing over here and let's try to fit it. Let me copy this also. So Control C and Control V, and let's see if we create this on the fly, and I'll copy the script content, and this is the context. I don't know if it'll work. Let's see. And let's try to send this request and see if it works. And if it doesn't work, okay. Okay, so looks like, of course, there is some formatting issues over here, some quotes and all that I need to fix. But anyway, you get the context over here, that in the content, you can also provide the context now. And in this context, now your large language model is capable of, let me do Control Z, and I can just type something over here that, whatever, right? So, context and properly formatted context and all that, and we can use some frameworks like LangChain to do this, but you can pass in the context, well, not in the system, but maybe in some other user prompt too, right? Like what is the OpenAI compatibility for Olama given below context, right? And you can then pass in the context over here, and we'll see all this in our actual RAG video. But this is how it is done essentially, that you pass in the context, and then in this context, this is the text that you will pass, right? So now this is one way of extracting text from your web page. But how much amount of text did you get, right? So if you see the actual web page, over here had a lot of information. but you did not really get all that information. You got some of this information, right? You did not get all of it. You did get some of it, but it wasn't really a lot of information that we could have passed. Now, let's say if we change this, if we use a URL that actually has some dynamic content loaded by JavaScript, right? So for example, this help SAP page, it is having a dynamic content over here. If we take and if we try to just scrape using our Beautiful Soup 4, right? So if we change this to this URL and if we try to scrape this, let's see what happens. And there we go. The scraped content is almost nothing. It got almost nothing out of it. It says that, yep, the website name is this, acknowledged, scraped at this time, paragraphs is nothing. It literally got nothing out of it. So how do we work with some more complex pages like this particular page or some other page that has more complex design, more JavaScript, where loading is done not simply by static pages, but by actual dynamic content? How do we do that? So in order for that, we'll have to move to take a look at some more dynamic ways of doing it, right? And that's where we'll take a look at Crawly, and we'll take a look at some other tools that will be used along with Crawly. But we'll build upon this beautiful soup concept too, right? So how we took the text from the response using the HTML parser and we created a soup. We will make use of this too, but we will add on some more tools on top of it. And I will show all that in the next video. So please stay tuned, watch my advanced crawling video to understand how we will get around the issue of not being able to parse or not being able to scrape content from pages that are more dynamic in nature. Thank you for watching, and I'll see you guys in the next video.